Hello and welcome to OH3 SPN Finland. Now, I've been intending to record this video for some time. In fact, I ordered the NanoVNA, I think it was towards the end of last year, and it took some time to arrive, and then when it did arrive I took it out, I had a quick play, I was quite impressed, and then I put it on the shelf. And there it has sat for the last couple of months, and I've been busy, I've been upgrading my PC, I haven't had opportunity to do video really. But today I figured I would take a look at this. I've mentioned it to a few friends online, and the reaction I've got is they look really nice, but they also look very complex. And the question that is probably fair to ask is, what use is this to me if I don't have a great knowledge of antenna theory? I just want to check my antennas performing as expected, which is quite a reasonable question. And a lot of these analyzers, they do provide a lot of data, some of which, or perhaps a lot of which, we're not necessarily interested in, but it gives the perception that you have to have a degree in radio and antenna theory in order to read these. So this video is really a quick introduction in how to get up and running with the very basics very quickly. So this is the NanoVNA. It's quite a small device. It came with a couple of connectors. It came with a dummy load, an open connector, and a shorted connector. These you can use to calibrate the device. I did do this, but I realised that the device came from the factory in China pre-calibrated, so it didn't actually make any difference. However, if you want peace of mind, you can go through that process. So the only extra thing I needed was a connector from the SMA type connector to my connector of choice, which is typically a SO239 or a N-type female. So here I have this connected to my main antenna, which is a HF antenna. It's from Spectrum Communications in the UK. It's a trap dipole. I know these may be a little bit out of favour now, but it's a very good, well-performing antenna. It covers 80, 40, 20, 17, 30, sorry, 10, and potentially 6 meters as well. It's basically 3 bands, 80, 40, 20, but with the harmonic bands you also get usability on 17, 10, and I think supposedly 15, but I need to check that. That's the current antenna. I also have a secondary antenna which I connected up, which is just a 20-meter dipole, which I connected up at the other side of the house. During the winter there was a bit of QRM from a neighbour, and that just got me up and operating without the high levels of noise from the other neighbour. So we turn on the device, and you have to excuse my poor recording setup. It was very difficult to get a camera that would look at this and focus, and you can see it's having difficulty now, but you can see the general gist of what's going on. And I think this is what puts a lot of people off. They see a display like this and it looks a mess. It looks very technical, and the camera is now not focusing. It was focusing perfectly during testing, and now I want to record, it's having difficulty, of course. But yes, this is displaying a lot of information, which is just clearly a mess. Now, this is an HF antenna. We can see the start frequency on the screen down here, which is 50 kilohertz, and the stop frequency is currently 900 megahertz. So that's a huge amount of spectrum. We can go in, if we tap on the screen, and we can select a start frequency. We're interested in about 3 megahertz up to, let's say, 60 megahertz. That will cover everything we're interested in. Now, this is showing the phase, the Smith chart, and various other bits and pieces. We're not necessarily interested in all of this, although it's good information to have. Let's go back. select the display. Now you'll have to bear with me here. Right, so we've selected SWR on the first trace. We have additional traces as well. Now we can disable these. So we can disable these by double clicking on the traces I've now discovered. And suddenly this is looking a lot more readable. So this is our SWR graph. Now this is covering still quite a wide frequency range. So let's change this. Let's check, let's say a stop frequency of 8 megahertz, which is perhaps a little bit more useful. Now we can see it starting at 3, stopping at 8. We can see a dip here and a dip here. Now we can use this connector, if I point to it, not connector, this control here, which is a left and right jog wheel, and you can see where the 1 is, and we have, if we take it to the dip of the SWR, we can see that the SWR is 1.1 to 1, and the frequency, so we've got SWR there, 1.1, and the frequency here is 3.6 megahertz, which is spot on. And then we can move this along until we get to the second dip, which I know is going to be about 7 megahertz, I certainly hope. And we can see it dipping down here. I do have some difficulty on the 740 meters band. As you can see, the SWR is about 3 to 1. It dips right down in the CW portion. But I think I've got some interaction with local objects on 40 meters. So it's not ideal, but with the ATU, it just brings it into a reasonable level. It's not so lossy there. So what about the other bands? Let's zoom in a bit. Let's say I want to look at, let's say 13.5 megahertz to 15 megs. And then we see we're zoomed in on the 20 meter band here. So if I go down to where, let's say the SWR is about 3 to 1, which is outside the band, 13.5 megahertz with SWR of 3 to 1. As soon as we come into, sorry, I was looking at the wrong thing, the frequency is up here, but it's still out of band. When we come into the 20 meter band, the SWR starts off very low, about 1.4 to 1, 1.4. As we're increasing, you can see it's raising to above 3, but at least on the significant part of the band I want to work, it's a nice low SWR. And I did say I had trouble, let's say 17 megs to, let's say 25 megs. Yeah, so here we see I have a dip around 17 megahertz, which is still acceptable in the lower part of the 17 meter band. I then have another dip here at about 22.4. It is reasonably effective on the 6 meter band, so if I say 45 megahertz, stop at 55, we can see here there's a significant dip just below the 6 meter band. We get down here, and again it's usable with an ATU. So what I'm trying to show here is you don't have to have all the displays enabled. You can just use it as a sweeping SWR meter so you can see where the dips are. And if you're out cutting an antenna to length or modifying it in any way, you can plug this in and you get a very quick representation of what's happening on the antenna. If we want to compare antennas, let's go back to the 20-meter band. We see here my main antenna has a dip, let's see, at the very bottom of the 20-meter band. If I now use my antenna switch and change to my secondary dipole, you see it has a much wider bandwidth. This is because it's a normal dipole. There's no traps involved, so the bandwidth is a little bit wider. If we... yeah. Plus the layout of it, I think, again, it's interacting with the surroundings. But in my case, in terms of SWR, it's actually working in my favour. So yes, that's the great thing. Now, this doesn't just cover HF. It covers up into the gigahertz as well. I'm not even sure at what frequency it stops. But if you're interested in 70 sems or 23 centimeters or 13 centimeters, I believe it goes up to those frequencies. So yes, in summary, you don't have to have a degree. You can just enable the SWR graph and you can do some very simple plots, and it doesn't require any theory, really. And years ago, when MFJ and I think some other companies started manufacturing the basic analyzers in a box without the LCD, I remember saying to people, why do you need this? Why can't you just use a grid dip oscillator for most of what you're doing here? You know, a $20 or £20 GDO picked up from a radio rally somewhere would probably give you as much as you need without having to spend the multiple hundreds at the time on a modern analyzer. But having bought this, having the SWR plotted on a display for a range of frequencies, I mean, if I was outside and I was trying to adjust the trap dipole and adjust the lengths, or, I mean, in a fan dipole, if you've got a multi-element fan dipole and you're trying to trim the legs, every time you adjust one, it interacts differently with the other elements. So to have all the bands that you're interested in mapped out visually on a display like this, updated in real time, I think is incredible, and I take back my comments on how useful a GDO is, although it still has its place, I think. This, for experimenting, at least with antennas, is a lot more useful, a lot more instant gratification, instant feedback on results. So I hope this has been useful. I might do another video at some point going into some of the more advanced functions, but really what I wanted to show here is the fact that you can turn these on, and with just a couple of presses on the screen, you can be analysing your antenna and plotting some SWR graphs. So that's it for now. If you have any questions or any suggestions for future videos, please leave a comment. And incidentally, I realised that despite not uploading new content for the last couple of months, I've just hit 500 subscribers. Now, I'm not really in this for the subscribers, but still, I feel like it's a bit of an achievement, so thank you very much. Until next time, this is OH3 SPN.